Hello guys, we are going to go ahead and do some more examples with rationalizing with not only square roots, but cube roots, maybe fourth roots, and then some extensions. All right, here we go. So in class, we talked about the square roots. And so I'm going to start with a quick review of dividing with radicals. And we're going to look at square roots. And I'm just going to do one example here. All right, so if we have, okay, let's say the square root of 4 over 18xy squared. Okay, so we need to think about the different ways we can do this. And the first thing I notice is that I can simplify. All right, because I see 4 and 18, and so I am going to reduce. And so I'm just going to put my 4 and my 18, and that's the only thing that I can notice that is going to reduce. So that goes to 2 and 9. All right. So now we get square root of 2, square root of 9xy squared. And then I notice that I've got xy squared. And so I have 3 different things here. And these 2 things are perfect squares. So I'm going to go ahead and simplify that. 3y square root of x. And now that I have that written down, I am going to think about what do I need to put in my box that's equal to 1, that when I multiply it together with the existing denominator, that I end up with a perfect square. And so the only thing we need to look at is the part that is left in the radical. And so that's going to be a root x. And I'm going to go ahead and just multiply these 2 things over here. And then I notice that it's a square root, so we get 3yx. All right, so I can see what my denominator is going to be because I have the multiplication. So I'm going to go ahead and write that in. And I'm going to simplify. I'm going to multiply this straight across. 3x y, and the reason I know that is because I already simplified it over here. All right, nice job. So that was a little recap of our square roots. So now we're going to go ahead and look at cube roots and how this is going to change when we have cube roots. All right, so for cube roots, instead of completing the square like I did in the previous problem, I am going to look for completing the cube. All right, first example here. Cube root of 3y over cube root of 4x to the 5th, y to the 4th. Okay, do I have any simplifying? I do notice that y over y to the 4th will become 1 over y cubed. Okay, so notice that this numerator is the piece that was moving. Right, see that? So that's why I subtracted the 1 in the denominator exponent. So let's simplify. So I have cube root of 3y over cube root of 4x to the 5th y cubed. And now what I'm doing is I'm looking for my perfect cubes. Okay, x cubed, x squared, and y cubed. All right, so these 2 pieces are my perfect cubes. So let's go ahead and simplify that. Cube root 3y over xy cube root 4x squared. All right, what are we going to put in this magical red box in order to, when I multiply, have this denominator be a rational number with no radicals? So I'm going to come up here because I'm running out of space. Okay, I'm going to write my denominator down. And I'm going to figure out what goes in this red box. And so the only thing I'm looking at is this radical. And so it's going to be a cube root. And I notice that 4 is a perfect square. And so I need to make it a perfect cube by, right? 2 is the perfect square, but I need it to be a perfect cube. So I need to multiply by 1 more 2. And x squared, so I need to be x to the first. So when I multiply these two things together, okay, let's see what we're going to get. Okay, so we get x, y, cube root 8x cubed. Now 8x cubed is actually a perfect square, so we're going to get 2x, which is actually 2x squared y. Okay, this is a rational number with no radicals. So I am going to multiply by 2x inside the cube root. Okay, what do we get? Cube root of 6xy all over. Notice I already did the multiplication here. 2x squared y. Woo! All right. Now, I'm going to do one more cube root, and then I'll do a short video about fourth roots and higher. Okay, let's see what we can do. Let's do 3 times, let's do 3x cube root of x squared y to the 5th, okay, all over, okay, the cube root of 12x y to the 6th. Okay. Can we simplify? Now, the only thing that I see here is I have a 3x outside the radical. Nothing can happen. I have a 1 over 12 inside the radical. So nothing can happen there. I have x squared over x, and yes, something can happen there. Okay. And then I have y to the 5th over y to the 6th, and that simplifies to this. Okay, right? Remember that when you have the same root, you can put the two pieces together and simplify. So I've got a 3x cube root of, okay, x, right, fraction bar, cube root of 12y. That's it. Do I have any perfect cube roots? So I'm looking at 12, and it's a perfect square and a 3, and that's all I've got. Okay, so I'm going to just put a little square around my 4 here just to remember that's a perfect square. Okay, and I have a y. I actually have a y to the 1st, and I need to figure out Okay, here's my scratch work. What am I gonna multiply by in order to make this a perfect cube? So I look at this and I've got right here, this is 2 times 2 and this is 3. And I'm looking for 3 of a kind. And so I need one more 2. Okay, but I also need 2 more 3s. And a little more space. Okay, now 2 more 3s, okay, is 9. All right, notice that we have a perfect square here, and so we only needed one more 2. Here, I didn't have the perfect square, so I needed 2 more of them. Then I look at y, and I've only got one y. And so what do I need to complete the cube? I actually need 2 more of them. Okay, so let's go ahead and multiply this together. All right, so it might be a little tricky. So we've got, wow, all right, 12 times 18. Oh, 216. Okay, so we've got cube root of 216 y cubed. That is a perfect cube, okay, because notice, okay, watch this. It looks like 8 and 27. This is 8 times 27. Okay, 8 is 4 and 2. This is 9 and 3. Look, a perfect square and 1 extra. All right, so perfect cubes. What does this simplify to? 8y. All right, so let's do it. Let's multiply in this really fancy radical. Okay, so what is this number? This is 18y squared. 18y squared. Okay, let's simplify. I'm just going to sort of block this off. That's my figuring out how to rationalize work. All right, 3x cube root of 18xy squared all over. Okay, notice I already did this multiplication right here, and it comes down to, oh, not 8y, silly, 6y. Because look, the perfect square is 2 and 3, perfect cube. So it comes down to 6y. Oh, no way. More simplifying with the 3 and the 6. Now, before I box that answer, I did look to make sure that I don't have any perfect cubes inside this radical right there. Okay, now, what should you be able to describe? Can you explain the difference between rationalizing with square roots and cube roots? Okay, can you explain the difference?